Donald Robinson, and as you may know, baseball is well regarded as America's pastime. But over the past 2 decades, baseball has grown and has become an international pastime all around the world. No matter if it's little leaguers on the baseball diamond dreaming of playing in the big leagues one day, or maybe even girls fast-pitch softball players prepping for a major tournament across the U.S. Baseball is revered as one of the most popular sports in America. In this video, we're going to explore how baseball relates to classroom learning. More specifically, we're going to examine the physics in baseball. Baseball is well known as America's pastime, but for many mathematicians and scientists, it also passes as class time. Batting averages is just an appetizer on a menu of number crunching options for the avid fan. Statistical models insist to determine everything from a Cy Young Award winner, which is pitching's grand prize, to a manager's contribution to a team. Scientists have a blast on game day. They use the laws of physics, for example, to explain why a head-first slide is faster than sliding into a base feet first. When the bat hits the ball goes flying. A lot happens in that split second as energy is transferred from the player's bat and then to the ball. We're going to take it out to Stephen Wade to explain a little bit more about this.
Remember Newton's 3 laws? Well, the third one says that every action has an equal and opposite reaction. So when there's a push on an object, the object pushes back. That's why even though gravity is still working on me, I'm not floating. The ground is pushing back up on me with an equal force. Next, momentum. Momentum is the last and it's the most important force in baseball. Momentum is a combination of the mass of an object and its velocity. So the faster an object is going, or the more massive it is, the harder it is to stop and the harder it is to get it going. Remember, I could throw this ball a lot farther than I could throw the bat. In a collision between the ball and the bat, not only is the bat moving about as much or even more than the ball, but the bat is 5 or 6 times heavier than the ball, so it always wins in a collision. Anyway, that's it. Hope you learned something.
Thank you, Stephen. We did.
Yes!
Nice hit. Physics is the science of studying energy in objects in motion. And with plenty of fast-swinging bats and flying balls, baseball is a constant display of physics in action. Scientists feed game-related data into specialized computer programs, like the one called PitchFX, which analyzes pitches to determine the speed, spin, and path taken by the ball during each pitch. For example, they can compare this pitcher's specific pitch to those thrown by other pitchers. The experts also can analyze the batter's swing to see what he did to make the ball travel so far. The most important interaction on the baseball field occurs between the pitcher and the batter. The pitcher throws a 90-mile-per-hour fastball 60 feet 2 inches away from the batter, and the batter has less than 4/10 of a second to react before it slams into the catcher's mitt. The pitcher aims for an imaginary square that's about 15 inches wide above home plate. The batter then attempts to hit the ball with the bat's center of mass, which is a 2-inch section towards the bat's center, known as the sweet spot. Even the best major league hitters only hit the ball 38% of the time at best. By the time the ball travels a dozen feet from the pitcher's mound, the batter has a good visual fix on it, and a thought process much too quick to deliberate. He or she must decide whether the pitch is a fastball, curveball, slider, knuckleball, screwball, or whatever. Yet a good deal of data has already gone into this instantaneous and nonverbal decision. During the entire middle portion of the pitch, the batter must time the ball and decide whether he's going to swing or not. If the batter decides to swing, he must start when the ball is approximately 25 to 30 feet away from the plate. The ball will arrive at about 0.25 seconds. That's 1/4 of a second. The batter must make contact with the ball within even a smaller range of time. He only has a few thousandths of a second error time that will result in a foul ball if he doesn't swing the bat at the right time. Position is important. Hitting the ball only a few milliseconds too high or a few milliseconds too low could either result in a fly ball or a grounder. Exactly how humans are able to estimate this expected position and quickly moving ball is unknown. Obviously, this is a remarkable skill that is learned through practice at a young age of eye, brain, and body coordination, which is acquired only through going through the motions over and over again from a younger age until you reach the big leagues.